In 2023, radio telescopes detected a repeating signal from a stellar remnant called GPM J1839-10. It pulsed exactly once every 21 minutes. This was followed by the discovery of ASKP J1832-091, which fires synchronized bursts of X-rays and radio waves in a strict 44-minute cycle. At these slow rotation speeds, standard models predict the star shouldn't generate enough voltage to overcome the resistance of the vacuum. According to the physics of neutron stars, these objects should be radio silent. Astronomers now suspect these aren't just cooling corpses, but active generators. They are identifying a class of objects that behave like literal cosmic batteries. These detections suggest that the Milky Way is threaded by a vast active electrical grid. The most extreme nodes in this grid are magnetars. These are neutron stars with magnetic fields reaching 100 billion Tesla, roughly 100 million times stronger than any magnet ever constructed by humans. A magnetar positioned halfway to the moon would possess enough magnetic energy to scramble the magnetic stripes on every credit card on Earth. Within 1,000 kilometers, the field is strong enough to physically distort the electron clouds of individual atoms, rendering the chemistry of life impossible. These properties make magnetars the universe's most efficient engines, capable of discharging energy that can illuminate or incinerate their surrounding star systems. This engine works on the same principle as a standard power plant. When a massive star dying, its core collapses. To conserve its angular momentum, that core spins faster as it shrinks. The Crab pulsar, the core of a 1,000-year-old supernova, rotates 30 times per second. This creates a massive reservoir of rotational kinetic energy, estimated at 1.4 times 10 to the 53rd ergs. In this cosmic generator, the spinning core acts as the rotor. The second component is demagnet, created by the star's super-dense conducting fluid interior. This is the magnetohydrodynamic dynamo. This dynamo process converts the star's internal heat and its rapid spin directly into magnetic energy. It is a natural version of the magnets and rotors found in a household generator, but with the mass of a sun. Even with this massive energy reservoir, the potential remains trapped within the star unless it finds a physical path to discharge. In the vacuum of space, releasing that power requires a closed circuit. Astronomers found evidence for this circuit around the red dwarf star GJ 1151. Though the star is normally inactive, it emits continuous high-power radio auroras. These auroras are sparked by an Earth-sized planet orbiting the star. As the planet plows through the star's magnetic field lines, it acts like a rotor, generating millions of volts and funneling a current of electrons straight into the star's poles. We see this mechanism at a larger scale in black hole accretion flows. This simulation tracks the transition from a disorganized magnetic state on the left to an organized, arrested state on the right. The disk then actively discharges its stored energy into space. Whether it's an orbiting planet or a rotating disk of gas, these connections complete the cosmic circuit, unleashing the star's stored power. The Crab Nebula is a real-time observation of this energy release. The bright central glow is synchrotron emission from electrons moving through its magnetic field. This debris is currently expanding at 3.4 million miles per hour because the dead star at its center is still pumping electrical energy into the surrounding gas. To replicate this on a human scale, physicists are researching quantum stellar batteries. This table shows the gap we have to bridge, from the energy density of a modern lithium-ion battery to an aspirational target 10 to the 14th times more powerful. This would require engineering topological quantum matter, materials where trillions of atoms act as a single coordinated unit. This state allows energy to be confined and released at stellar densities without being lost to the environment. Theoretical structures like these could eventually allow a civilization to capture the entire energy output of a star. Understanding this cosmic grid reveals a universe that isn't a silent void, but a vast power plant, with enough energy to sustain a billion-year civilization or dismantle a star system.